Okay, now in the second part, I'm going to introduce this toolbox called DPABI. This is one of the toolbox that's actually combined SPN12 as well as the racing state analysis that we introduced in the first section. So as you can see that DPABI, or another toolbox called DPARS, is actually developed by this Chinese researcher, Yan Jiagan, actually. And he first published the DPARS, this toolbox, in 2010. Actually, now it's accumulated over 1,700 citations right now. And even another updated or evolving toolbox called DPABI that we're going to use today, published in 2016, is actually cited for more than 300 times. So I think this toolbox actually helped lots of people to perform, I think, including the image preprocessing and the racing state analysis right there. So you can see this is a brief introduction of DPABI. DPABI is actually evolving from DPARS. This is actually the original toolbox published in 2010. And you can see that they all based on the SPN. So if you want to use this DPABI or DPARS toolbox, first of all, you need to download SPN. So if you run DPABI or DPARS and you see an error messaging showing on the MATLAB command window saying that there is no function of SPN, that means you need to download SPN and include SPN path into MATLAB first. Okay. So for the DPARS right here, DPARS is actually composed of two different parts. The first part is it will automatically process or perform the FMI preprocessing steps. It's originally developed a pipeline, or you can customize the pipeline that including slice timing, realignment, segment, normalized smoothing, or even filtering or removing some covariates or confounding covariates. You can just do that using this DPARS platform. And for the second part, you can perform the racing state FMI analysis. As we introduced in the first session, even a rewhole or ALFF or modified version F, ALFF, you can use this DPARS, the panel, or DPARS, the interface, to do the analysis. Of course, there are several other analyses you can perform, but today we will focus on these two analyses right here. And for the download website or this website, you can find out the original coding, and the original author also provide the online videos right there. So you can go to this website, and if you want to learn more detail about this DPABI platform, you can just visit the website. So I think we have at least 3 to 4 different steps that if you want to use DPABI to finish the racing state analysis. So the very first step is the data organization. Before using DPABI toolbox, you need to organize your data set in specific way, okay? So first, you need to create a study folder. In our case, we have a folder called FMI Analysis 09 materials, okay? This is the study folder. Then under the study folder, you need to create 2 specific folders right here. One is named as Fun Row, FUNRAW, and the uppercase for F and R. You need to create the identical folders right here, okay? Another one is T1 row. Look at the uppercase for T and R right here. So you can see this is our study folder. You will have 2 folders with the identical names right here. For the fun row directory, you need to create several different subject folders right here. So you can see within a study, you may have recruit 10, 30, or maybe more subjects right there. So you can just create a different subject folder. In our demonstration today, I only create one subject folder named sub underline 001 for both fun row folder and T1 row folder. So under fun row and T1 row directory, you will find out you can put several different subjects data within these subfolders. So you may name the subject as sub underline 001, sub underline 002 under these folders. But today we only have the sub underline 001. And within each subject folder, you will put all the DICOM files within these folders. So for the fun row data for each subject folder, in our case, we will have 200 DICOM files under each folder. So you can check all the data set within this structure, okay? After you carefully organize all the data in this fashion, right now you can start using the DPABI toolbox right here. What you should do is, first of all, you need to open MATLAB. And again, you need to set the path. So you can find out the set path under the Home tab right here. And you need to ensure that you have both SPN 12 path as well as the DPABI path right here. So for the DPABI, you need to add with the subfolders, and you need to identify the DPABI toolbox directory, I think right here. Just include always the subfolders. But I have already included the path before, so I won't click OK right now. Okay. So please ensure that you have all the SPN 12 as well as the DPABI path within the MATLAB path. Okay. Then you click Save and Close. If you set the path correctly, now you can key in DPABI on the MATLAB command window right here. Okay? And then you will see the welcome message and a notification that you should cite their paper correctly. Just press OK. Then you will see the DPABI panel right here. Okay? So what you should do is click the first button to launch the DPARS toolbox right here. You can see under the DPARS panel right here, there are several different functions or buttons you can select. But in this class, I will use the advanced edition. Of course, you can go for basic edition with less parameters that you can control. However, if you can, just go for advanced edition right here. So this is the advanced edition right here. We call the parts with an A right here. If you use basic edition, there will be B right here, okay? So for this panel, let me shrink this one, okay? You can see there are so many different buttons or checkbox or edit on this panel because the author tried to incorporate all the preprocessing steps in this panel. So you can see maybe above, I think around here, above this line, right here, above this line, all the functions above this line are the preprocessing steps. So the author actually incorporated all the SPM functions under the DPARS panel right here. And for the functions under this line right here, they are the potential options for resting state analysis. For example, you can see there is ALFF and fractional ALFF right here. You can also find out there is rehold right here. Okay, so you can just pick what kind of function or what kind of steps you like to use under this panel. To save your time, I actually create a pipeline file for you. So what you can do is to load the pipeline file that I provided to you. So just click the load button right here and just go to the folder that I provided you today. So you can just go to this package, fMRI analysis 09 underlying materials. You'll find out there is a meta file called DPARS advanced pipeline for rehold. There's another that I prepared for you is for ALFF. Of course, with FALFF, okay? So now you can, first of all, pick the rehold. So you can see all the options are changed based on what I said before. And the very first things you need to do is to set the correct working directory. So now you need to select the folder to what I provide to you, this one, okay? Just select this folder as the working directory. And as I mentioned before, that you need to, of course, remember that under this study directory, you definitely need this fun row and T1 row folder with subject folders containing all the DICOM files. Then you can process all the images correctly, okay? So now go back to the parse panel right here. So you don't actually need to change all the parameters. What you need to do right now is select the correct working directory, then come to the right lower corner right here. You can see there is a starting directory name right here. Okay, so you can see the default variable right here is a fun row. That is the string that the system will try to seek for. So you definitely need to put a so-called fun row directory under the starting directory, right? If you really want to change to others, you can actually change by typing some words right here, okay? But I will recommend you to use the default value. Just follow the rule, okay? So fun row. Click the enter right here. You will see there is a tips information right here to tell you that actually after the process, you will have so many different folders with so-called post-fix. You will see that later. Okay, so this is the information message. You can either leave this window or just click OK, okay? So now you can see if there is no error message showing you that they cannot find the fun row directory, that means you set the pathway and the starting directory name correctly. So you can see now we only have one subject under the folder. If you have subject on the line 002, you will see the full list right here. But now we only have one subject, so you can see this right here. Okay? So once everything is done, just click the run. Then the MATLAB will start to process all the imaging right there. Okay? So click it by yourself. I won't do it right now. It will take so much memory on my computer, so I won't do it now. Okay? So right here, let's go to here. You can see this is the first step, second step. And once you start the processing, you will see lots of the information print out on the MATLAB command window. And specifically, you will see SPN slice timing, SPN realignment. That's because the parse keep using the SPN functions for all the preprocessing steps. And once the preprocessing are done for the fMRI imaging, racing state fMRI imaging, you will see there is a warning messaging window pop up telling you that the system cannot automatically identify the co-registered T1 imaging. Do you want to use the original T1 weighted imaging as the imaging to process? Just click yes. Okay, just click yes. Okay? So now I'm trying to go through all the preprocessing step or parameters that you can set up right here. So you can see the first one is the EPI DICOM to Nifty. What we did in SPN, we used the DICOM import, right? And then I want to use the apply math because this is actually the way you can apply the orientation matrix, but we didn't do this before, so I won't do it right now. And for the fMRI, especially the temporal analysis, normally we will discard or remove the first 5 to 10 time points data because for the beginning 5 to 10 time points, normally the imaging didn't reach so-called steady state, as well as the subject didn't really enter the racing status. Normally we will just discard the first 10 time points. With TR equals to 2 seconds, that means we will discard the data from the very first 20 seconds. Okay, it is a normal state that if we want to perform some temporal analysis on the fMRI data. Then we will do the slice timing just like the SPN. And this is the parameters we need to set up. The slice number is 40. The slice order interleave for Siemens machine is 2, 4, 6, all the even number followed by the odd number. Reference slice is 1. I have already explained this to you for the next week, for the previous week. Realignment to correct the brain motion during the fMRI scan. Okay. And right here we will use the so-called auto mask. This one is the way that we can we can extract the brain region without the scalp, skull, or other non-brain tissue region. Okay, so this is the auto mask that we can simply retrieve or do so-called the skull stripping step right here. Okay, and then this is the part for the fMRI. Now we will go to the anatomical imaging. Again, we will start from the T1 DICOM to NIFTY. Then we will do this again. BAT is one of the approach that will do the skull stripping. Just extract the brain tissue region automatically. This is I think this is an algorithm actually retrieved from the FreeSurfer, another package, can do automatic skull stripping. Then we will do the co-registration step, that we will co-register T1 anatomical imaging to functional imaging. So just give a check. Then we will do the tissue segmentation. Now we want to use the old segmentation that is actually incorporated in the SPN12, but we use a new segmentation approach that provided by Darto. This is another approach. Okay, and again for the imaging normalization, we will use the regularization term based on the East Asia brain. Okay. And then followed by this, you can see you can find out some normalization parameters like the bounding box, voxel size. Also, you can perform the smooth step right here with the FWHM AA8. Okay. And there is something else that called nuisance covariance regression. Normally, when we perform some similarity analysis for the temporal board profile, we will try to remove some covariance that is actually estimated from the Y-meter regions and the CSF regions, because we normally think that the brain activation or brain activity is mostly originated from gray-matter region. So we will treat the signals from other region as the covariance. We will try to regress out. We will try to remove the compounding effect from all other regions. So we will pick this one. Okay. So as you can see right here, the upper panel is actually trying to give you a pipeline to do the imaging preprocessing. But there is one thing that I'd like to emphasize is, if you want to perform the rehold, do not perform the smooth before you calculate the rehold. It's because smoothing will definitely change the regional homogeneity. So what is recommended by the original author, they say do not perform smoothing before rehold. There's another option right here. You can see, you can check the rehold and smooth rehold afterward. Do not perform smoothing before, but perform the smoothing after rehold. That is what they recommended. Okay, so once all the process is done, I think it will take 10 to 20 minutes, depends on the performance of your PC or notebook. But after 20 minutes, if you successfully to see this information on the MATLAB command window, congratulations, the running of the parse is done. That means you finished all the process. Okay. And to this point, you can find out actually so many different folders within the study folders right there. So this one, you can see T1 row, this is the original folder, as well as the fun row, this is the original folder. And besides these two folders, you can see so many different folders right here, including different steps. For example, fun row and fun imaging. This means that the system already convert all the DICOM files into the NIFTY files. Then you will see fun imaging with an A, with a postfix of A. That means slice timing. So now you have already had the NIFTY files with slice timing. Then with R, realignment. So you can see AR. Then C is covariance removed anyway. So you can see there are so many different folders following different steps right here. So you just confirm whether you have all the results from different steps right here. Okay? And this is very similar for the T1 imaging. T1 imaging will have a batch process to do the skull stripping. Then you will have a step for the co-registration. So the T1 image will be co-registered to the functional imaging. then perform the segmentation. So you will again have the C1 map, C2 map, and the C3 map. Okay, so you have so many different things. But normally, we won't really go to every directory to check every result. We will directly see the results right here. This is the final result. For example, if you use the ALFF pipeline, the results will having so-called ALFF folder inside. If you use a reho, you will see the reho result inside. So let me show you my results. I prepared two different folders that actually perform with different pipeline. This one is for ALFF, this one is for the reho. So for the reho, you can go inside, find out the results folder right here. Go to the results, you can see now we have reho folder right here. Okay, so now I'm going to show you the ALFF folder. Again, now I go to the ALFF folder right here. You can go to the results folder right here. Now you can see ALFF along with the FALFF. Okay, so you can see if you use different pipeline, you can see different results. What I recommend is please do not put reho and ALFF result together, because actually the preprocessing steps are different between these two different analyses. For reho, you don't want to perform smooth before reho calculation. For ALFF, you need smooth before ALFF. So for me, I actually create two different directory, two different study directory. Within these folders, you can just pick any one. For example, reho. You can see there are so many different nifty files right there. And as you can see, the Z represents the Z value. Normally, we will convert the value to the Z value so we can better get the threshold. And if for the reho file, you may see there is an S before Z. That means smoothed reho. Okay. We will calculate the reho, then perform a smooth analysis right there. So you can try to open the imaging using the micro right here. So you can see this is actually the reho result with a smooth effect right here. Again, you can also see the ALFF or FALF right here. So just pick one of them. Normally I will pick the one with Z, that means Z score. Okay. Pick this one. So this is actually the ALFF result. Again, if you want to perform any statistical analysis, you can go back to SPM using the second level analysis. Just treat this map as the SPMT map. They have a pretty similar structure right there. But for the DPABI, they also provide a result viewer. So what you can do right here, if you finish the process, go back to the main panel of the DPABI. There is a viewer button right here. Okay, just click the viewer. And now there is a new window called the DPABI viewer right here. What you can do is now you can see this. There is a underlying structural image right here. This is actually come from the one of the T1 template. But now what you can do is you can try to overlay a result image on it. So what you can do, just go to this one browse button. You can actually select the 5 different overlay images. Now we just pick the first one. Okay, I want to use the maybe reho imaging. So I go to the reho result directory. I try to select the smooth version. So SZ reho map. I will use this one. Press accept. Now you can see this is the reho map overlaid on the underlying structural image. But now this is pretty ugly, right? You need to do some thresholding. So we try to threshold the Z value. We just preserve the highest one right here. So now you can see this is actually so-called default network. You can see there are significant activity on this region or regional homogeneity on this region. This is actually, I think, involving the precuneus region and the posterior cingulate cortex. How to see this if you are not that good at the image atlas? Again, there's an option, a button right here. Click this atlas. Then you can select some default atlas right here. For example, AAL that I introduced to you in the first 2 weeks. Click this one and again, click accept. Now, this review, this view panel will automatically show you what is the current cursor indicate. Now this is located in the precuneus, right? Now close to here, you can see this one is the posterior cingulate cortex right here. Normally, the deformable network will include the bilateral supramarginal region right here. For example, higher one, this one, angular region or supramarginal region right here. And then we will have a prefrontal region right here. This one would be the medial superior frontal regions right here. So you can, this is actually the typical pattern for the deformable network, okay? And now you can also view the result for the, you can add another overlay. You can maybe now see the result from the ALFF right here. So now I go to the ALFF result folder. I pick the Z map again. So now what I can see, I can just uncheck the first one because now I want to see the result from the ALFF. Okay, just uncheck the first one, just leave the second one checked. Again, I can adjust the p-value, adjust the threshold value right here. Now I can see, even I use the ALFF, I can see very similar pattern. Again, this is a deformable network. I can again, using a different approach, calculate the amplitude of the low frequency band. I can see very similar result compared to the rehold right there. Okay, so now you can easily switch from different overlay. You want to see the first one, just again do this. You can see the result is pretty similar. Okay, so they also provide a very similar one called a slice view. What you can do, they call slice view as the montage right here. So you can click 3 different view: actual view, sagittal view, or chronal view. Maybe I want to pick the actual view, just click the button right here. Now you can identify how many rows, for example 5 rows, 10 columns. I'd like to display the slice view. Okay, and I want the increment of the slice thickness is around 3 millimeter. After you key in the parameter, just click the apply. And wait a moment, you will see this is a slice view, but they code it as the montage. Now you can just switch the page by clicking the right or left arrow right here. So now you can easily to see, okay, this is how the actual views showing the deformable network right here. So you can see this is the precuneus and the posterior cingulate cortex right here, and the angular or supramarginal regions right here, as well as the medial prefrontal cortex right here. This is so-called, sometimes we call tripod of the deformable network. Okay. So now we only have one subject, so I can only display one subject to you. But there's another thing that besides the overlay, you can also change the underlay. You can change the underlay not using the T1 template, but you can using the subject's own T1 imaging. Okay, so come to T1 imaging new segment right here. Just pick one. No. This one. Okay. W means normalized. Okay, I just want normalized. I don't want the C1 map, C2 map, or C3 map. I want the normalized structural image. So now I underlay the subject's own T1 weighted imaging. So this may be better to show the subject's anatomy. Okay. So this is a way that you can view the result. If you're really not familiar with the imaging atlas, there's another option called structure right here. If you have already assigned the AAL as the atlas, they provide pretty similar function that you can click on the atlas name and it will automatically bring you to the location. Okay, so if I want to see whether the posterior cingulate cortex is one of the target region, let me find this one. I can just click on this one. So pretty close to the activated region right here. Okay. So I think this is the brief, I think, go through to show you how to use the DPABI toolbox as well as the parse toolbox for you to perform the so-called racing state fMRI analysis right there. Basically, rehold and ALF that you can do using this toolbox. Finally, if you have multiple subjects image on hand, you want to perform one sample, two sample, or pair t-test that we mentioned in the SPN environment, you can do that using this button, statistical analysis right here. But today I didn't provide you multiple subjects data right there, so you cannot do this today. But if you want, just go check this function and just select a pretty similar way. You can do statistical analysis based on the result, ReHo or ALF result you obtained. Okay. So I think that's all for today. Please check that you can really finish the process for at least one subject. So you may try this later if you have your own data on hand. Okay. So any question?